Example 2 is looking at solving matrices using Cramer's rule, which we just learned. If you want to, just follow along as I solve for part A, and then you can try part B on your own. If you feel very confident, you can try part A on your own right now. Just pause the video and resume when you're ready to check your solution. To use Cramer's rule, the first thing I want to do is set up the augmented matrix. Doing that, I get the matrix 4, -3, -5, +7, 3, 1. The next thing you want to do is solve for determinants. We have 3 determinants we want to solve for. We want to solve for d, dx, and dy. D is just the main part of our matrix, 4, -5, -3, 7. For dx, we keep the same y column, but instead of x's, we use the solution values. And for dy, we keep the same x column, but instead of our y column, we use the solution values. Thus, for d, I get 4 times 7, which is 28, minus -3 times -5, which is a +15, and this gives me 13. For dx, I get 3 times 7, which is 21, minus 1 times -5, which is -5, and this gives me 26. And then finally for dy, I get 4 times 1, which is 4, minus -3 times 3, which is -9, and that gives me 13. The last step you want to do, let's give a little bit more room here, is now solve for x and y. I know that x is dx over d, and y is dy over d. Thus, x is 26 over 13, and y is 13 over 13. X is 2, y is 1, so my final answer is the ordered pair 2, 1. Let's look at part B now. You can try this one on your own first, pause the video, and resume when you're ready to check your solution. First thing I do is come up with the augmented matrix. -1, 2, -1, 3, -3, 3. Then I want to come up with d, dx, and dy. I know that d will be using the determinant for -1, 2, 3, -6. dx is -1, 3, 2, -6. And dy is -1, 3, -1, 3. I then find that d is +6 minus 6, which is 0. dx is a +6 minus 6, which is 0. And dy is -3 minus a -3, which is again 0. Okay, when this happens, first of all, if you get the determinant equals 0, it means that your x and y's in the second equation are just a multiple of the first. So it means one of two things. Either we have no solution or infinitely many solutions. What we find is this: if you get that x is 0 over 0, then this means there's infinitely many solutions. If x is some number not 0 over 0, then there's no solution. Same thing for y. So if both x and y are 0 over 0, it means there is, the 0 over 0 is infinitely many solutions. And then for some number over 0, we get no solution. So in this case,